Hello, ladies and gentlemen. This video is going to cover converting quadratic equations from standard form to vertex form using completing the square. So what is completing the square? Completing the square is when we take our standard form of x squared plus bx plus c and convert it to our vertex form of ax plus h squared plus k. So, and why would we do this, right? Well, if we look at our standard form here, and I was asked to graph it or find the solutions, if it's not factorable or something, we have to use quadratic formula. We can't graph it for sure without using some shortcuts. It just doesn't tell us a whole lot of information about our quadratic. This, on the other hand, it tells us our vertex. It tells us our axis of symmetry. It tells us a whole bunch of information just by looking at it. So that's why we'd want to do that. So, we're going to just jump right into this and solve a couple of these. So the first one is going to be x squared minus 6x plus 8. So the first thing you want to do is make sure that the coefficient of x squared is 1. And we have that here. We look here, we have nothing, which signifies a 1. So what I want you to do is I want you to take those first two terms. Well, let's rewrite it first. X squared minus 6x plus 8 equals 0. So you're going to take these first two terms, give yourself some space, put them in parentheses. So you have x squared minus 6x, and you're going to leave that empty. Then you're going to do plus 8. So it should be an 8. So here's what we're going to do. We're going to take this middle term here, negative 6, and bring it down. So I have negative 6 divided by 2 equals negative 3. Now put a triangle around that because we're going to come right back to that. Square that, and that equals 9. Now this 9 we're going to add here, so this will be our plus side, plus 9 here. And we're going to subtract 9 here. Subtract. Now, if we look at this right here, we can see that this is a perfect square trinomial. However, I'm going to show you a shortcut in order to factor this. So we could put our parentheses again here. Now, my negative 3 that I have in my triangle, there's a reason I put a triangle over it, and that's so you know that this number is going to come right in here. Now, if we remember, our perfect square trinomial factors like this. Now I have plus 8 minus 9 gives me a negative 1, and that equals 0. So we get y equals x minus 3 squared minus 1 as our vertex form. Now we can tell what our vertex is. Our vertex would be 3, negative 1. Our axis of symmetry is x equals 3. And go from there. It's opening up. We could graph this, everything else from here. All right, so that's completing the square. Let's do another one. I have x squared plus 6x plus 7. Again, make sure our coefficient is a 1 here. If not, we'd have to divide everything by our a term. Our a is 1. So let's go ahead and give ourselves some space here. X squared plus 6x, and leave that gap again. Plus 7. Now again, our plus 6 here is going to come down. 6 divided by 2 equals 3. This time it's a positive 3, so make that note. Square that, and that's 9. So again, here we add 9 plus 9, and here we will subtract 9. So again, our shortcut here is we're going to have x this number plus its sign is going to come down here, plus 3 squared. And then we have positive 7 and minus 9 gives us a minus 2. So our vertex form is y equals x plus 3 squared minus 2. However, let's say we're solving for this, right? So I'm going to carry this up here for us. X plus 3 squared minus 2 equals 0. Well, if we're solving for x, we're set up pretty simple right here, right? My first step here would be to plus 2 over, giving me x plus 3 squared equals 2. To get rid of my squared term here, I square root both sides. Remembering that this is a plus or minus square root, so I have x plus 3 equals plus or minus square root of 2. And my last step would be to subtract 3 over. So if I were to solve for this, I'd get x equals negative 3 plus or minus the square root of 2. And you could check that by using the quadratic formula for this one as well. So let's go ahead and do another one, last one. This one, we'll notice that the coefficient is not 1. So to get it as 1, we have to divide everything by that front term. So what that gives us is we get x squared here, which gives us our 1 coefficient, minus 1 half x minus 5 over 4. So again, we're going to give ourselves some room here, parenthesis, x squared minus 1 half x, leave ourselves some space there, minus 5 over 4. And we're going to take this term down again. I have negative 1 half. This time, since it's a fraction, I'm not going to divide by 2. I'm going to do the equivalent to that, but it makes it easier with fraction, and that's multiply by 1 half. That gives us negative 1/4. Put our triangle around that and square it, and that is 1/16. So, again, add that here. And subtract it here. So again, on this part, we're going to use our shortcut, bring this negative 1/4 down. So I have x minus 1/4 squared. And here I have to do a little bit more math, getting equivalent denominators. So 4 and 16, our common denominator would be 16. Multiply this by 4 over 4. So that gives a negative 20 over 16 minus 1 over 16. So our final answer would be x minus 1/4 squared. Negative 20 over 16 minus 1 over 16 is a negative 21 over 16. Again, if we were solving that, set it equal to 0. Alright, so we'd add 21 over 16 over. Sorry if you guys hear my dogs playing in the background. They're roughhousing. X minus 1/4 squared equals 21 over 16. To get rid of our squared term again, we square root both sides, plus or minus square root of 21 over 16. X minus 1/4. Oh, don't need those. Equals plus or minus square root of 21. Square root of 16 is 4. And then we just add our 1/4 over. So x equals 1/4 plus or minus square root of 21 over 4. And again, you could check that answer with the quadratic formula as well. And you could see how it would look a lot like it if you did get the same answer. All right, there's your standard form to vertex form using completing the square. Hope to see you in class and answer any questions you have. Thank you. Have a great day, evening, morning, whatever time it is for you while you watch this. Thank you.